Very good morning, good afternoon, good evening, my dear friends and students. I am Raghunandan Sengupta from the IME department, IIT Kanpur, and welcome to this TQM2 lecture 7, which is the second class in the second week. And as you do remember, we were discussing about initially about point estimation, then went into details about interval estimation, and then came into hypothesis testing. And I did also mention about with a background or with a small problem of a bank loan being given by a manager. So, there would be one set of people who would default, one set of people who won't default. Based on that, you find out alpha and beta, which is type 1, type 2 errors. What are those errors? So, we did discuss about H naught, null hypothesis, HA, alternate hypothesis, and how they are contradictory, complementary, and then you try to solve. Then we also did mention, and I am going to mention it time and again, that when you want to find out something to do with the population mean, given the standard deviation of the population or the variance of the population known, we use the Z distribution, and Z distribution as we know is symmetric with a mean value of 0 and standard deviation or variance of value of 1. Now, in case if it is again to something to do with the population mean and in the case the standard deviation of the variance of the population unknown, then we use the T distribution with a certain degrees of freedom being lost. Why they are lost, we did discuss, where we use S dash, S without the dash, and so on and so forth. Then we did also mention that T distribution is symmetric, hence when you take T to the left, T to the right, you have T minus T alpha n minus 1 or minus k, the loss of degrees of freedom whatever it is, alpha or alpha by 2 depending on how the example has been framed for the hypothesis testing. And on the right hand side it will be T n minus 1 or n minus k as the case may be, with alpha or alpha by 2 depending on the whether it is basically one sided, both sided, and all these things. Then we came into the second, the big area about trying to find out something to do with the variance. The variance can be found out when you are trying to compare with the existing population. One population, you use the chi-square with certain degrees of freedom being lost or not being lost. It won't be lost when you know the mean value of the population, it will be lost, and you will reduce it by 1 if the population mean is not known, because in that case you use S without the dash, and in the case when population mean is known you use S with the dash. Then when you go to the case when you are trying to compare two different variability, variance, dispersion, and all these things, then we use the F distribution. Now, F distribution have 2 degrees of freedom, M and N, M being for the first population, first sample size, N being the second population, second sample size. And in that case you are trying to use the S dashes for both the samples. In case if the population means, respective means mu 1 and mu 2, the 1 and 2 are the suffixes, are not known, then you use S without the dashes in both the populations for the samples, and we use F m minus 1 n minus 1 accordingly. So with this again I will continue, concept will be same, repeated time and again, but it is just to make you well aware and have a very clear cut picture in your mind how these frameworks are be done. Obviously, there is a lot of theory here, but we would not consider it in details because it is not required for this TQM2, it will be required for a rigorous course in statistics, probability, and inference techniques. So, suppose we draw n number of random observations, and it is a normal distribution. So, obviously, the observations are random variables are x, capital X suffix 1 to capital F suffix n, and sigma square, which is the population variance, is unknown. Then we want to compare the mean value. In the H naught case, it will be the mean is equal to mu naught under H naught being true, with respect to HA, which is the alternative hypothesis, where mu is equal to mu A, which under the alternate hypothesis, and mu A is less than mu naught. So, obviously, it will be the left hand side, as it is something to do with the mean. You want to first answer the question whether it is Z distribution or T distribution. It is not Z distribution because the variance is unknown. So, you use the T distribution. So, if you are using the T distribution, remember that you are using S without the dash. So, coming back to this problem, it is on the left hand side. So, you will take only the left hand one tailed values. So, only remember which I am again repeating. So, if it is on the left hand side, I am clicking here on the formula. So, this would be x bar n, which is the sample mean for a sample size n, being less than mu naught under h naught, minus, but because minus sign would be, as you are looking at the left hand side, it will be minus t suffix n minus 1, as you have already lost 1 degrees of freedom. Number second point, importantly, it will be alpha because it is one sided, and obviously in place of sigma you replace by Sn, and in case of square root of n, it remains as square root of n, being divided in both the cases, in the z distribution case and the t distribution. In case it is on the if the hypothesis is basically h naught remains same, but h is greater than type. So, obviously you will look on the right hand side, the diagrams you remember which we had already discussed, it will be on the right hand side. So, in that case the formula becomes x bar n is greater than mu naught plus, because it is as it on the right hand side, the value would be added, plus t suffix n minus 1 alpha into Sn by square root of n. If it is on both sided, which means h naught is mu naught and h a is mu a is not equal to mu naught. So, obviously it will be divided. So, the middle portion would be the whole overall area covered would be 1 minus alpha, and the left hand side and right hand side the total sum is alpha, but is equally divided by alpha by alpha by 2 and alpha by 2. So, in this case you will reject h naught if this component is true, that is the mod of the difference between the mean value of the sample and its population value is greater than t n minus 1, n minus 1 remains same, but in case of alpha it gets replaced by alpha by 2 and Sn and square root by of n remains the same. So, if this is true, obviously you will reject h naught. Now, let us go to the case when you want to find out something to do with, given the mean value is known, so of the population. So, if it is something to do with the population variance, obviously you will either the chi-square or the F distribution, but if it is, as it is only one population, you will use chi-square, but you would not lose any degrees of freedom because the population mean is known. So, without going into the details, because we have repeated it time and again, I will come to the rule and it will become very simple for you to understand. So, your rule would be that you will reject h naught if it is a left hand side hypothesis. Why it is a left hand sided hypothesis is that we will compare the ratios of the variances under h naught is equal to 1, and under h a it will be less than 1 because of the less than type. So, obviously in that case s dash or s star whatever it is, and this is s dash or s star because the population mean is known as mentioned here, like in the blue color where I am highlighting now. So, this is less than sigma square naught, which is under h naught, and it will be chi square n because you do not lose any degrees of freedom, 1 minus alpha because on the left hand side, and this is alpha not alpha by 2 because it is one sided test, divided by n. In case it is the hypothesis is of this form, h naught remains the same, h a is of the greater than type, which is sigma square suffix a divided by sigma square is basically greater than 1. In that case you have on the right hand tail test, which is s dash square is greater than sigma square naught by chi square suffix n, and in this case it is not 1 minus alpha, alpha and divided by n remains as it is. If it is both sided, which means that you have h naught again the same, but in this case h a is when the ratios are not equal to 1. So, obviously it is two sided. In this case if it is two sided, you will reject h naught if both the left hand as well as the right hand or the right hand are true. In the sense you have basically s dash being less than equal to chi square n 1 minus alpha by 2 into sigma square suffix not or 0 under h naught. So, this is 1 minus alpha by 2 because it is one sided divided by n as it is, and in the other case on the right hand side it will be everything remains the same, only the greater than sign comes, and in place of 1 minus alpha by 2 it becomes alpha by 2 for the suffixes of chi square. In case if you want to find out something to with the population variance, given the mean value of the population being unknown, then the formulas which we just discussed are exactly the same with few changes, and mark those changes very carefully. So, for the first case, hypothesis less than type. So, stop, pause, think, where are the changes? S dash or S star gets replaced by S, is that true? Let us check. Yes, it is true. Now, in the case what happens to chi square? Does it lose any degree of freedom? Yes, because you have already lost 1 degree of freedom, because you have used the population mean being not known being replaced by a sample mean, hence you have lost 1 degree of freedom. So, it will be chi square n minus 1, and also in the case of division being done by n, it is gets replaced by n minus 1. So, there are technically 3 changes. S dash gets replaced by S, chi square with a certain degree of freedom loses 1 degree of freedom, and the division on the right hand side becomes n minus 1 and not n. In case if it is a hypothesis of the greater than type, again the same formula, only the greater than size is replaced, and as usual 1 minus alpha gets replaced by alpha as shown, where I am basically hovering my cursor this. Now, in case the rule says that it is of the both tailed, that means it is in H naught remain the same and H A is basically not equal to, in that case it will be S without the dash less than and S without the dash greater than. But in this case the same thing happens, it in place of n it gets replaced by n minus 1 in the denominator, and the suffixes for chi square now becomes n minus 1 in both the cases and not n, and obviously in place in the earlier case it was 1 minus alpha, now it becomes 1 minus alpha by 2, and the other case for the greater than type it was alpha, now it gets replaced by alpha by 2. Now, I want to find out something to do with the differences of the sample means, considering the population means are not known and you want to compare them. The same example which I did discuss yesterday, the factories are producing same type of products in 2 different locations, their mean values, weight or length or tensile strength or say for example viscosity, whatever the product you are trying to measure, on an average there is difference. So, if you think there is no difference, so under the null hypothesis the difference between the mu 1 and mu 2, which is the mean value of population 1 and mean value of population 2, would be 0, and if you take up samples which is x bar m and x bar n, m and n being the sample size which I am picking up from population 1 and population 2, when I try to compare them, obviously it comes to the case that if the values are 0, then obviously it is matching with the population differences, but if it is not, obviously you have to test the hypothesis. So, in case if sigma 1 and sigma 2 or sigma square x suffix x and sigma square suffix y for the 2 populations are known, then obviously you will use the z distribution. So, and the formula exactly the same. The mean value or the difference of the mean value, sorry, this suffix n should be below y. So, if the difference between the sample means is less than or equal to the difference between the population means, and obviously there will be a minus sign because on the left hand side z alpha comes as usual, and the pooled so called variance or the variance of this two population becomes sigma square suffix x divided by m plus sigma square suffix n divided by n, sum them up and find the square root. In the case, see for example, when you have the hypothesis of the greater than type, so what is the null hypothesis? The difference between the sample means is 0 with respect to the case when the difference of the sample mean or the population mean is population mean is less than 0 for the less than type, greater than 0 for the greater than type. In this formula everything remains same. So, only the less than type formula is replaced by greater than type, and in front of z it was initially minus, now it gets plus. In the third example where we have, if we have say for example the hypothesis, null hypothesis remain the same, alternate hypothesis is basically the differences of the means are not equal to 0, then obviously you have in the case the values being not equal to 0, it will be left hand side and right hand side which is two tailed. So, in this case the sample mean is less than the difference between the population mean minus z alpha by 2, because this alpha is being equally divided on both sides of the z distribution. Then the bracket part which is something to do with the pooled variance remains the same, and in the other case or it is other things would be true if based on which you will reject H naught is when the difference between the sample mean is greater than the difference between the population mean plus z alpha by 2 and then multiplied by the pooled sample population variance. In case if you want to find out something to do with now which I am just scrolling up, I have not written the formula, but it will become clear to you. In case say for example, you have to do something to do with the hypothesis testing of the difference of the sample means given the population variances are not known. So, obviously you will be using in place of sigma square x and sigma square y the corresponding S, which is the standard error for sample 1 and sample 2, remembering the population mean is not known, hence you will basically lose 1 degree of freedom in the sample 1, 1 degree of freedom in the sample 2, hence the total degrees of freedom would be m plus n minus 2, where m is the sample size of taken up from population 1 and n is basically the sample size taken from population 2. And you will basically have the rules accordingly. Now, for the less than type it will be t distribution, not z, and for the greater than type again t distribution, and for the not equal to type again the t distribution, only changes being t distribution in all the 3 cases would basically lose 2 degrees of freedom, one from the first sample, one from the second sample, and in the less than type greater than type it will basically be 1 minus alpha and alpha, and in the not equal to type, which is the two tailed, it will be 1 minus alpha by 2 and alpha by 2 for the suffixes of t which I am talking about. Now, I want to find out something to do with the variability of two products, like the same example which I gave. Tie rods are being manufactured, bottles are being filled up with jams and jellies, carton box are being filled up, dimensions of or different type of tubes are being measured, and rather than finding out the mean values performance, we want to find out the variability. So, if that is something to do with variability, we immediately know that it has to something to do with the chi-square or the F distribution, but now we are trying to compare two different variabilities from two different populations considering their two different samples. So, in that case we will use the F distribution, but now you have to pause for 1 minute. Point 1, you will ask your question whether the population means are known. If it is known, so you know that there would not be any loss of degrees of freedom, because you will be safely using S dashes in both the cases, S dash suffix m or S dash suffix n, depending on the sample size being m and n from population 1 and population 2. So, in that case it will be F distribution suffix m comma n. So, m is in mango, n is in Nagpur, and very interestingly both the names are from synonymous to the same concept, like mangoes and Nagpurs. I thought of trying to mentioning that because that will make things very clear for you to understand the concept of m sample and n sample. Now, when I take something to do with the comparison of the sample variances, so obviously in the less than type, so how the less than type is being formulated, the null hypothesis is that the differences between the variances or the ratios between the variances under the null hypothesis is either 0 or 1 respectively, as the case may be, and in the case when it is the alternate hypothesis, the less than type, the difference would be less than 0 or the ratios would be less than 1. So, in that case you will reject H naught if the ratio of S dashes for the first sample and the second sample is less than f m comma n minus 1 by alpha, because it is the less than type. For the case when you are taking the greater than type, which means the differences is 0 under the null hypothesis and or the ratio is 1, ratio means the ratios of the variances of population 1 and population 2, and in the alternative hypothesis the difference is greater than 0 or the ratio of the variances for two population is greater than 1. In that case you will reject H naught if the ratio of sample variance of population 1 and population 2 is greater than f suffix m comma n comma alpha, because you know the right hand side. In case if the null hypothesis remains the same, the alternative hypothesis is not equal to, that means the differences is not equal to 0 or the ratios of the variances of population 1 and population 2 taken from trying to basically replace them with the sample variances, if that ratio is not equal to 1. So, you will reject H naught if these two conditions, this or this, are true. In the first case, the variances ratios of the samples from some sample 1 and sample 2 corresponding to population 1 and population 2 is less than f m comma n 1 minus alpha by 2, and in the other case it will be greater than f m comma n comma alpha by 2. Now, in the almost the last example which you are going to consider, it is again to do with the sample variances, a comparison of the population variances. So, we use the sample variance, but we ask the question that whether the population mean is known. It is not known. So, we can assume that we will definitely use S without the dash in both the samples, and once we are assured of that, and we also know that will use the F distribution with losing 1 degrees of freedom from both sample 1 and sample 2. So, let us basically see the 3 cases I am not going to repeat the hypothesis because they are exactly the same as for the example we just discussed. So, the null hypothesis remains equal to for all the 3 cases. The alternative hypothesis consecutively are less than type, greater than type, not equal to. So, in this case I will just mention them if I have seen, yes. So, I will mention them, I have not written them, but it will be easier for you to understand. So, in this case it will be S without the dashes, the ratios of them less than f m minus 1 n minus 1 1 minus alpha by 2. In the greater than type would be S without the dashes ratios greater than f m minus 1 n minus 1 alpha by 2, and in the last case when it is not equal to, it will be less, the ratios are S without the dashes ratios less than f m minus 1 n minus 1 comma 1 minus alpha by 2, and or it will basically be, you will reject H naught, or the condition is S without the dashes ratios being greater than f m minus 1 n minus 1 alpha by 2. Now, as I did mention, so say for example, suppose we draw m and n observations from 2 different populations, trying to basically find out the difference in the means corresponding to difference in the population means, and we do not have the population means. So, you use the sample means, but only thing is that the population variances are unknown and they are unequal. So, I will first repeat the hypothesis. So, the null hypothesis in all the 3 cases is the differences between the population means is 0, and the alternative hypothesis in the 3 consecutive cases are the difference between the population means is less than 0, difference between the population means is greater than 0, and difference between the population means is not equal to 0. So, once you have that, you will definitely first ask your question that if as it is something to do the mean, should we use the Z distribution or the T distribution? Now, it is no more Z because the population variances are not known. So, if the population variance is not known, you will use the T distribution. But when you are using the T distribution, you will basically ask the question, what am I using? Am I using S without the dash, or am I using S? So, obviously it is S because there you lose 1 degrees of freedom both for sample 1 and sample 2. So, hence the T distribution would be with a suffix where it is m plus n minus 2, because 1 being lost as a degrees of freedom from both the population. So, obviously the rules for the less than type, greater than type and not equal to type are, as I am mentioning, consecutively like this. The difference between the sample means being less than equal to the difference between the population means minus the t value, where the t value is with suffix m plus n minus 2 comma 1 minus 1 minus alpha, or alpha would not be any different for the T distribution, because if you remember I did mention this symmetric, but only the minus sign is coming. So, it will be m plus n minus 2, and actually it is 1 minus alpha multiplied by the pool variance. In the case of the greater than type, it is greater than equal to, this difference between the sample means is greater than equal to the population mean plus the same value of t, but now 1 minus alpha is replaced by alpha, even though it is not written in the less than type, multiplied by the pool variance. And in the case when it is not equal to type, obviously it would be less than equal to or greater than equal to. So, in the less than equal to, it is the difference between the sample means is less than then the difference between the population means minus t m plus n minus 2 comma alpha by 2, because it is both sided, again multiplied by the pool variance. And in the case it is greater than type, for the not equal to type, it will be greater than difference, the sample mean is greater than the population mean plus t m plus n minus alpha comma alpha by 2 multiplied by the pooled variance. Now, with this, even though I have gone a little bit fast, please bear with me, we will be coming back to this concept time and again, and with this I will slowly start the concepts of say for example, analysis of variance will be very important, and go slowly as we solve problems accordingly. So, now we start with the analysis of variance or ANOVA. Now, first we will basically describe it in detail with solved examples, and slowly try to understand how the concepts which we have used, like for the almost the 6 classes and almost half of the 7th one or lectures about the concepts of hypothesis testing and something to do with parametric point estimation, interval estimation, how they will be utilized. So, definitions of basically what we mean by experiment. To really understand the cause and effect relationship in a system, you must deliberately change the input values to the system and observe the changes as they are happening in the system. or output, that these changes have been affected by the input change. So, say for example, you are trying to utilize some type of temperature control, some type of humidity control, or some type of different type of coolant, or some say for example different type of catalyst which you are using for either for a mechanical process or for a chemical process, for these examples which I mentioned, and you want to test that what is the change in the output is happening for the input. So, other examples which you consider, say for example, the hypothesis examples we are considering. And the last example which was not written, but it did discuss, is that in Maharashtra the sugarcane is basically one of the biggest production of crop. So, now you want to find out that using the change in the fertilizer or using the different type of irrigation system, what changes it will have on the output. Output is basically the crop output per acreage or per kilometer square or per hectare. So, consider this as I change the input, it may be humidity, it may be temperature, it may be irrigation system, it can be fertilizer, all these things. So, or it can be some different type of mixture of soils which I am trying to utilize. So, based on that, when I or can be, say for example, different type of initial input which I am giving, maybe some nutrient which I am trying to basically give to the soil or to the crop for higher yields. So, based on those input changes, I want to find out what are the output change. Output change is basically very simply, for our example in this one which we discussed, would be the increase or decrease in the per acre or per hectare output. So, in other words, you need to conduct experiments on the system. So, each experiment which we do to test would basically be considered to test these type of test would be considered a test. So, we want to conduct a test to find out what is the changes. We can define an experiment as a test or a series of runs in which the purposeful changes are made to the input variables of a system or a process, so that we may observe and identify the reasons for the changes that may be observed in the output or the responses. So, consider this. So, what we have, so I will try to basically now highlight this. So, consider you have set of inputs which is yellow highlighted, and there are basically two sets of variables which are there. So, I will try to highlight it again. So, one is the uncontrollable factors which you cannot control obviously as per the experiment, and there are other sets of controllable factors, and based on that you basically have an output. So, your main task is to basically find out the comparison of say for example the input and the output in order to basically understand how the whole system changes. So, with this figure let me understand, and this has been taken from Montgomery book. So, all the figures with they have been given their due recognition, and the IPR rights have been taken into consideration. So, I am just stating them as it is. In general, the experiments are used to study the performance of processes and system. You usually visualize the process as a combination of operations of machines, methods, peoples, and other sources that transform some input, often a material, into an output that has one or more observable responses. So, such of the processes variables and the materials are basically termed as x1 to xp. So, which are controllable, and z1 to zq. So, this z is nothing to do with the standard normal deviate, which are uncontrollable, although they may be controllable for the purpose of the experiment, but we will consider, or for the test we will consider them to be not under control. So, the objectives of the experiment would be, the objective would be as following: determine which variables are most influential in the response. Y can be a scalar or a vector, and obviously inputs are a vector starting from x1 to xp or x1 to xn, depending on what terminology or nomenclature we are trying to use. We will determine where to set the influence of xs, so that y is almost nearly as the desired normal value which we want. Determining where to set the influences of x's, so that the variability in y is also small. So, there are two things: we want to change the x values, and we want to basically get the exact value, which is something to do with the expected value, but we want to basically keep the variances as low as possible, as at the same time trying to maintain the expected value would mean something to do with the consistency of the experiment. If you remember, we did mention that trying to find out the unbiasedness and the consistency were the two important properties of finding out. and we will also determine. So, these are not the main points, but only. So, these are the absolutely very essential when you are trying to understand how the test is to be conducted and what are the important things we should remember. We should also remember where to set the influences of x's, so that the effects of the uncontrollable variables, which is z1 to zq, are minimized and kept to the lowest level. So, with this I will end the 7th lecture and continue discussing about the design of experiments and slowly build up the overall atmosphere and the environment, such that we will try to analyze the problems and also see that how later on we will be utilizing all the concepts which we have studied about the hypothesis testing and point estimation and something to do with the interval estimation, and the concepts and the general framework will be utilized time and again in our design of experiments and studies. And obviously, there would be more concepts, but please bear with me, we will slowly cover as and when they appear. We will discuss them in details and make it clear to all the students and all the people who are taking this course. With this, I will end the 7th lecture, and let me wish you have a happy day, and thank you very much for your attention. Bye.